Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Workload Cloud Placement Factors with Cloud Solution Specialist Rico Dutton. Rico, welcome to the show.
Thank you, Darren. Thank you for having me on here.
So, Rico, you're part of our public sector team, and you are you our only cloud specialist, our only technical cloud specialist?
I think within our little public sector org, I think so. Yeah, at least directly within public sector. Yes.
But you're augmented by a huge cloud solution architecture team that Intel has, right?
Oh yeah, no, we have an absolutely massive team behind me, supporting me. People with certifications from all the various CSPs, years of specialized workload experience, and really just extensive experience having to do with all things related cloud. So I'm directly in our public sector team, but behind me we have a massive and robust cloud support organization.
Okay, before we go tout all those guys, Rico, everyone wants to know when they hear people on the show, they want to hear your background. So give us a brief, not 30 minutes, not 30 seconds, somewhere in between 30 minutes and 30 seconds. Your background, where'd you come from? Why are you at Intel?
Yeah, sure, absolutely. So I've been working, I guess, in the IT field, kind of in a sense, with a big boy job for probably about the last decade or so. And what really made me choose the career field in the first place was I'm an avid gamer. So gaming was kind of how I got my interest in ultimately building gaming PCs. Because at the time, if you wanted to play the latest games with the greatest graphics and the highest settings, you had to play on PC. In order to do that, you have to obviously, you can buy a pre-built PC from an OEM, but I always like building them myself. Being able to
most ultimate gamers do, right?
Yeah, exactly. Yeah. I could never just buy pre-built off the shelf. I don't have it in me anymore. No disrespect to people who do, but I just can't do it. Not at this point. But that was kind of the genesis of it. Started with that, and then in high school, I was fortunate that my high school actually offered we could get certifications while in high school. So I got my A+ during high school, and I also got my MCP and MCDST. And the MCDST at the time was the Microsoft certification. This was back in the Windows XP days, kind of the XP leading into Vista and early Windows 7 days, where that was kind of like the entry mid-level certification, the MCDST. So that was kind of what got my start and interest in this career, and I kind of just kept following it along. And when I started working, for real, first big boy job, as I like to say, I began at a small MSP, and really in that role, anything that plugged into a wall or used electricity, I got the opportunity to deal with. So that was servers, client devices, networking, websites, web hosting, all that good stuff. So that was I did that for a few years. I got a lot of operations experience in that role, and then pivoted to pre-sales about 7 or 8 years ago. Pivoted to the pre-sales, sales engineering side, and kind of did that for several years, and then wound up a couple years ago taking interest in the cloud. Got certified on AWS. AWS was kind of how I learned cloud personally. And then from there, Intel one day reached out. And I'd never worked for such a large organization before, at least an organization at the scale of Intel. So I saw the opportunity, and I decided, hey, you know what, let's go for this. Let's see how this goes. And now I'm here.
That's awesome. So from gamer to cloud solution expert. Yeah, that's pretty good.
Yeah.
Pretty good. Are you still game? Do you still game in the evenings and the weekends?
Oh yeah, I still do.
It's in your blood.
Yeah, man. Yeah. I want to say maybe a little bit less now, just because there hasn't necessarily been that title that just reaches out and grabs me lately. But hopefully that will change, because there's a lot of good stuff coming out. I know everyone's loving Baldur's Gate 3 right now. That might be one I have to take a look at for sure.
All right, so we're going to have to come back, and you're going to have to come back on the show and do some kind of gamers review. That'll be
Oh,
awesome.
that'd be fantastic. Yeah.
All right, so let's dig into the subject today, which is workload placement in the cloud. When I first heard this subject, I was like, well, no, duh, just move everything to the cloud. That's what we've been told, right, by Amazon and Azure
Yep.
and Google. Hey, just run your stuff in the cloud. The cloud's this ubiquitous big thing. Just put it there.
Yeah.
Is it that simple?
I think we all wish it was. You could just put everything in there, and then you wouldn't have any you wouldn't run into any issues doing that. But unfortunately, it's not always that seamless and that easy. There are several factors you need to take into consideration before you move a workload to the cloud. First and foremost, being ultimately the business drivers and the business outcomes. What does the business want to ultimately get out of that application, and how can moving it or not moving it to the cloud really enable that outcome? That needs to be kind of the first thing you start with before you start looking at what applications to move, or even to move to the cloud at all, quite frankly.
Wait, you said even move to the cloud at all. Aren't you a cloud solution architect? Isn't everything supposed to go to the cloud? Come on, Rico.
Yeah. Well. To backtrack a little bit. No, I'm kidding. But on that, so cloud is not just a place. It's an operating model,
Okay.
right? So what you do,
Oh, okay.
yeah. So what you can actually do is you can operate your on-premises or existing infrastructure as if it were a cloud, right, a public cloud, and you can do that by implementing technology such as virtualization. You can implement virtualization. You can add support for things like container platforms. You can add support for things like microservices, automated provisioning, automated networking, infrastructure as code. You can implement all these technologies and concepts within your you can implement all those concepts within your existing infrastructure. And when you do that, you'll be able to have a cloud-like experience, with your on-premises infrastructure.
Okay, that sounds like a lot of work though. Is it a lot of work to stand up, because you're talking a private cloud in
Mhm.
this instance, right? Is it a lot of
Yeah,
work to stand up my own private cloud, because you mentioned virtualization, automation, like a self-service
yeah.
portal, or are there products I can go out and buy
Mhm.
today that help me with my own private cloud journey?
Yeah, sure, absolutely. I mean, I think the difficulty in that journey will kind of depend on where you're at. I mean, every organization is at a particular step along that journey. So if for example you're all bare metal today, let's say, and you're not running a whole lot of virtualization, you're gonna have a bit of a longer path than an organization that's already embraced technologies such as virtualization and has already embraced technologies such as containerization, etc. But ultimately, I think any organization can get there because the benefits of modernizing and the benefits of doing so, I think, ultimately far outweigh the potential costs involved as far as upskilling your staff, investing in new software technologies, new infrastructure technologies, etc. But there are several companies and software stacks that can help you along and help you do that. I mean, most people are familiar with VMware. That's a good first step uh, in just virtualizing. A good place to start is just virtualizing what you have, right? So if you're running on mainly bare metal today, you can start by virtualizing as much of your environment as you can, and just take that first baby step. Just start with the virtualization. Start virtualizing what you can, and then from there you can start looking at, oh, okay, now I have a VM. Could I maybe move some of these VMs to the cloud? Or do I want to go further and start looking into containerization? Do I want to perhaps start virtualizing my storage? Do I want to start virtualizing my networking? I mean, like, what do I really want to do with this, and how far do I really want to take this? And which of these various technologies can benefit my application and my organization as a whole? So those are kind of the things you want to start thinking about if you're early on in your virtualization journey.
Okay, most organizations have some kind of virtualization. right?
Yeah.
Most, unless you're small, right?
Yeah.
Um, so how do I decide as far as I've got virtualization? I may have the glimpses of a private cloud, but I like how you called it. It's operating model
Mhm.
change.
Yeah.
So it's no longer provisioning machines for specific applications.
Mhm.
It's provisioning VMs that can run across multiple machines
Exactly.
and things
Yeah.
like that and portability. How do I make those decisions on what workloads I'm now going to target
Mhm.
to the cloud? What are those workload requirements that I have?
Gotcha. Sure. Well, that really depends. I hate to give the answer. It depends, but it really does depend.
Well, it does. But what factors are they that I need to at least tease out? For example, if you were to come in and help me with my workload
Mhm.
requirements, what do I have to come prepared with?
Sure, absolutely. So there are several factors you need to take into consideration. Um, chief among them, I would say, is probably mainly performance. So, what are your latency requirements? Um, how close does your application need to be deployed close to the end users? That's another important consideration. And there are also things like data custody, data privacy. If you need to have the data reside in a certain geographic location, that's going to be another factor you have to take into consideration on if you migrate the workload, and ultimately if you do choose to migrate it, where does that land? um, and then you also need to consider security is a consideration you have to look at as well. Is this data that I can afford to move out to the cloud, or is it so sensitive that it's better if I keep it within my own network boundary and my own network firewall? So those are just a few of various factors you want to look at when you're deciding what workloads you want to move to the cloud, or if you want to move to the cloud, with those workloads in the first place.
So, I mean, technically, can I move any workload to the cloud technically?
From a technical perspective, you could, although there are
But there's
various.
there's some costs,
Yeah,
right?
yeah,
And like you mentioned, I love how you mentioned data sovereignty
yeah.
and compliance to data locality. Those are issues. But technically, there's nothing really stopping me from taking a VM and moving it to a cloud. That technology exists,
Mhm.
correct?
Yeah, no, it exists. It definitely exists. There's nothing stopping you, but then you may, depending on the application in question and how it's architected, you may run into various issues such as it may not be as performant in the cloud, or if you have a lot of data transfer costs, what can happen is you can the bulk of your if an application isn't architected correctly, the bulk of your cloud spend could wind up being ultimately data transfer costs, because generally the way most CSPs work is that you can move data in just fine. There's no issue with that. But when you want to take it out, or you're moving it even between regions within a certain CSP, it's possible to get hit with hefty data movement charges that you're not prepared for. So that's something.
Right. We call that part of the Hotel
Mhm.
California
Yeah,
effect, right?
yeah,
You can
absolutely.
check your data in, but you
Mhm.
can't check it out.
Exactly. Yeah, and an unfortunate drawback of that, and something we see a lot, is that a lot of organizations, they will move workloads up to the cloud, but then ultimately they wind up moving them back, essentially repatriating them back on prem shortly after that, because the applications in question weren't the ultimate cloud architecture wasn't necessarily thought all the way through before that migration was made. So it's really important to, I'd like to say, measure twice, cut once. I would really think through, I'd really think through, which applications you're moving, and ultimately the application architecture. Like, how is this application going to look once it's in a CSP's environment? Those are the factors.
That's really interesting because what that tells me is when I do a migration, I have to intimately understand and know my application because you're talking about data. So if I have an application that's doing some kind of data callback
Yeah,
or um, or callback to an external source, I'm paying I'm paying for data egress. Anything moving out of the
yeah.
cloud, I'm paying for.
Yeah, no,
So
absolutely.
yeah, so I've got to intimately understand my applications before I move them.
Yeah, absolutely. What you don't want to do is, if your application has problems, you don't want to take your problems to the cloud with you, because that can ultimately wind up significantly increasing the costs and the size of the bills that you receive on the back end after you do that.
Well, you're going to know real quick,
Yeah.
aren't you?
Oh yeah. You're gonna find out real quick on that.
In fact, I've got a story around that. There was a really large customer. I'm not going to mention their name because it's kind of embarrassing, where they were mandated by government to to put some of their supercomputing cluster in the cloud.
Mhm.
So they had a high performance computer cluster, and so they did because it was mandated by law that some of the money that they had to spend.
Mhm.
Um, and they put one node up into the cloud, and the rest of the cluster was in their data center.
Whoa.
Oh yeah,
Yeah.
they ran through their whole year
Yeah.
budget in cloud. They ran through it in like 2 months
Yeah.
because HPC clusters are notorious for being chatty,
Yeah.
for sharing data back and forth between cluster
Mhm.
nodes. And yeah, they just it just went through the roof.
Yeah.
So they found out real quick. Are there any other hidden costs? I'm calling them hidden because when you run the calculators, because all the CSPs have
Yeah. Oh yeah,
calculators,
for
right?
sure. Mhm.
Um, that's a hidden cost because you don't really know how much data you're going to move in and out of the cloud until you start doing it.
Yeah. Yeah.
Are there any others like that you know about that we need to be careful of?
Yeah, sure. I mean, another one, you mentioned the data, that's a key one. But another one I would say is also making sure you have the talent in your organization, or namely have access to the talent to manage those resources once they are up in the cloud. Because it can get expensive if you're bringing in outside consultants in kind of an ad hoc basis to manage your cloud environment. So I think what would help a lot of organizations in that case to manage essentially to manage their talent pool and their workforce costs is to make sure you're able to um, both retrain or train your internal staff on how to operate a cloud environment, as well as make sure you're able to bring in the right outside talent to help you manage that. Because I think it's better to build up that talent and build up those skill sets within the org rather than going outside the org in kind of an ad hoc basis that can really uh, essentially rack up the people costs and human costs when.
So if I'm a CIO
Mhm.
and I'm using a traditional organization where I have network engineers,
Yep,
storage engineers, and rack and stack server
gotcha.
guys,
Yep.
where do I look? Is it all three? I can pull from all three.
Mhm.
Where would you look first to retrain someone to be more cloud centric?
Gotcha. No, sure. Excellent question. So all the CSPs have their own training and certification path. And actually, at Intel, we actually have our own cloud solution architect and cloud engineer path as well, that can help teach those skills across multiple clouds. But I would say just start small, start with the basics. Like even something as basic as a cloud practitioner cert, or just an entry level CSP cert. Start with that, and then you can essentially build up the stack and go into specialized areas. Because even within the cloud, I mean, you still have networking in the cloud, you still have storage in the cloud, you still have compute. Those things don't go away. What simply changes is, instead of them being in a data center that you manage, those resources are now in another organization's data center. So the resources are still there. They've just shifted where they are. So the skills are still there, and they're still very much applicable to the cloud model. And another benefit of that is it gives the workers within the organization the opportunities to learn new skills, and start to effectively cross train in areas that they may have had an interest in before, or they had an interest in before but couldn't necessarily do, because prior to moving to the cloud, they were very much siloed in their little. Okay, you're a storage person, you only do storage. You are a compute
You
person,
only
you
do
only do
storage, yeah,
compute.
yeah,
You're a
yeah.
networking person, you only do networking. Um, so I think moving to the cloud opens up several opportunities to upskill and cross train on various different disciplines, and that
Great.
includes.
Okay.
Yeah.
Okay, you said moving stuff up to the cloud, and we mentioned before the cloud is not all the same.
Yeah.
I think of it as that way, right? Because I've been sold that, hey, the cloud is ubiquitous. I've got compute, storage, and network.
Mhm.
Hey, those are consumable by like electricity out of the wall.
Yeah.
All my electricity in my whole house, except for one plug, is 120. I got 220 from my dryer.
Mhm.
That's it. Is that the same in the cloud? Where, hey, I just go to compute, all the compute is equal. All the instances on computer are equal, all the storage is equal, network is equal. Or do I still have a lot of variability in that I have to make decisions from?
No, absolutely. You have in the cloud, you still have tremendous amounts of variability in the compute because what happens is on premises, for example, you can have various choices of which compute you land on, which compute you use. In the cloud, that's still very much the same, and there are definite distinct benefits of running on one architecture versus another, or choosing one accelerator versus another. So all those decisions that you would still have made on premises, you'll still need to make them in the cloud. Now, one thing that's unique about Intel is that really, and one reason why I love being here is that we're ubiquitous across all the clouds. Right? Be that, I mean, again, Amazon, Azure, Google Cloud, Oracle, IBM Cloud. I mean, even some of the foreign CSPs, Tencent Cloud, Alibaba Cloud. We're all over the place. So no matter where you choose to run your workload or which cloud you choose to run it in, Intel can be that consistent, ingredient silicon brand that essentially rides underneath all of them. But the decision on which compute you land on is just as important in the cloud as it is on prem.
Okay, so what is available in the cloud today? I mean, because in my data center, I have stuff that's 15 years old and 7 years
Yeah.
old and 3 years old,
Mhm.
right? I mean, that happens
Yeah.
in every single data center, right? Is it the same in the cloud? Do they have stuff that's really that old that I may, and those are probably the cheaper one, the cheaper instances,
Yeah,
right?
yeah, sure. No, they definitely do. There's definitely a mix of instance and compute families within the CSPs. So one thing that the CSPs will often do is a lot of those older compute instances, which are really backed by older generations of compute hardware and compute CPU generations. They'll take a lot of those older generations, and then they will actually take those older servers. And once they take them out of kind of the traditional IaaS, infrastructure as a service provisioning pool, what they'll do is they will actually take a lot of those servers and have them handle a lot of the serverless compute functions. So if you're familiar with such as an Amazon, an AWS Lambda, or an Azure Functions, just as two examples, a lot of those, when you make a request using those services, a lot of times that actually winds up landing on some of these older machines because it's just you're basically paying per function, and that utilizing it was more it's fairly cost effective to utilize those older
Well,
machines.
yeah, because they've already
Yeah,
depreciated
yeah,
all their
exactly.
costs,
Yeah.
right? So they're keeping around really old machine. Probably first gen Xeon is probably still running
Mhm.
in the cloud. And what is that? 8 years old, 9 years old?
Yeah, yeah, and
Um,
even older than that, honestly. Yeah,
really? Wow.
yeah. But you can go
So
from that. You can go from there all the way up to the latest and greatest in Sapphire Rapids, because that's now being rolled out to the cloud service providers. And which instance you land on, I mean, there can be a world of difference in landing on say a I don't know, an Ivy Bridge based Xeon versus landing on the latest and greatest, Sapphire Rapids. There's a huge delta in performance there between those two instances. So it's
yeah,
really
something like
yeah,
10x,
yeah,
right?
yeah, yeah, possibly even more with accelerators. I mean, definitely more with accelerators. So it's really important to understand those various instance families, those instance generations, and taking that into consideration when you're choosing what instance to land on. Because another interesting tidbit with cloud computing is the CSPs actually, when they release a new generation of instance into the cloud, oftentimes the actual price for that instance that you pay per hour, it isn't that much more than the prior generation instance. A lot of times it may be the
Really?
same. Yeah, it might actually be, it may be the same price, or it may just be, pennies on the dollar per hour more. So basically, what happens is when you move to a later generation instance, it's actually possible to get more performance for the same amount of money that you've been paying. So that's another reason why it's important to really keep up on the latest, either keep up on the latest instance families or implement modern DevOps practices and modern cloud native practices to make sure that when possible you're always landing on the latest and greatest instance,
Gotcha.
because you're
All
actually
right.
leaving
So
performance on the table when you're not doing that.
yeah, yeah, exactly. Well, and there's this trade-off, right? Price performance
Mhm.
trade-off that
Yeah.
you have to make. Does Intel have any price performance metrics that I can use, or do I have to just do this myself? Through experimentation, or is there somewhere I can go to help me make a decision on? I have an SQL database.
Mhm.
What's the best instance for that to land on? The brand new Sapphire Rapids, or is Cascade Lake good enough, or do I go to Ice Lake? There's all these different generations of Intel processors out
Yeah,
there.
sure, absolutely. So one thing that myself and a lot of our cloud specialists are very good at is instance selection for that particular workload. That is a conversation that if you're an organization that you're not sure, which instance or which cloud, or ultimately just generally not sure what to do as far as this whole flat cloud thing is concerned, you can definitely reach out to us and we'd be happy to help assist you in choosing the proper instance. But we also have tools that help with that. So Densify, Intel Cloud Optimizer, also known as Densify. That's actually a tool that helps. That's a tool that helps make sure you're landing on the proper instance for your workload. Because what Densify is actually able to do is it's able to use machine learning to actually understand which instance features an application is and isn't using, as well as how much compute, how much networking, etc. the application is using, and it can take all that into consideration and choose the right size instance for that particular workload. So one thing we've seen is a lot of organizations will actually implement Densify's instance recommendations into their Terraform scripts. So what will happen is
Oh,
that,
interesting.
yeah. So pretty much when a workload is spun up, it's always going to land on the latest, or rather the most performant instance for the work that needs to be performed.
For the work that needs to be done. Very cool stuff. One last thing.
Sure.
You said everyone uses Intel. All the cloud service
Mhm.
providers use
Yeah.
Intel. Is it exclusively Intel? Do they have their own stuff? And then do I have an issue with portability if my stuff is running on Intel, uh, you on-prem,
Mhm.
and I move it to the cloud? Is there any issues with incompatibility running in the cloud? And then repatriating as well. Is that an issue at all?
Mhm. Sure. So right now, Intel in the cloud, we comprise about 90% of the world's cloud instances. So the world's clouds run on Intel right now. So if you're looking to port an x86 based workload from on premises and move that up to the cloud, Intel landing on an Intel instance is the natural fit for that. But we are experiencing competition in the cloud. There is still AMD is still in the cloud. There are AMD based instances that we compete with in a similar vein to the on premises world, and there are also a lot of ARM based instances. The most I think well known one is AWS Graviton. So ARM, what it is basically ARM is a company and they license out their intellectual property to other companies, and they can make CPU chips with that. So the ARM IP, you can think of it as it's very similar to what's likely in your phone or mobile device, but it's scaled up to server scale and a server platform. So that's another architecture that we do compete with. But the issue with with Graviton and ARM-based processors in general, is that they tend to be very specific to that CSP, and you don't have a lot of workload portability between not just between different public cloud providers, but also between the public cloud and your on-premises or private cloud environment. It's very hard to port workloads in between those environments, and that's another consideration you have to consider if you're looking to migrate to ARM. There'd be a lot of refactoring and redevelopment of code that would have to happen if you're looking to move from an x86 based workload to an ARM based workload. And at Intel, one thing we've seen the demand for that very performance per watt optimized compute. Cloud providers, both end users and cloud providers, they want to be sustainable. They want to make sure they're getting the most performance for watt that they can. And one thing at Intel we're actually looking at, we actually saw all of that, and we are actually going to address that in our roadmap. So the upcoming Sierra-Forest-based processors are going to be very competitive in that regard.
Energy efficient type.
Yeah, because you're going to get all those performance per watt benefits while still being able to maintain that legacy code compatibility with the x86 architecture.
That's awesome. Hey, Rico, this has been very insightful. If people want to find out more information, they just reach out to Intel. What is there a certain? Just send Rico your email. Everyone in the world.
Just send it my way. I'm happy to help. Yeah. I'll even if it's about gaming, I'll respond twice as fast.
Yeah, of course. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.